Hi everyone. I'm just going to try to keep your video as short as I possibly can. So if you look on this blog, you'll see that there are notes that are attached. They're attached as a PowerPoint as well as a PDF. So you have both versions available if you have something wrong with your computer or one version works better than another. I'm going to go ahead and start right into this. So we are getting ready to start on covalent bonds and how we write compounds that, or how we name compounds that have a covalent bond. So you've been working on ionic compounds, which there's an ionic bond that's formed between those two. And an ionic bond is where you have an attraction between this positive charge and this negative charged anion, positive charged cation, and we've called that, remember, that Coulombic attraction. So covalent bonding is a little different. In terms of ionic bonding, we know that one electron or two or three will completely leave the atom of the cation and move over to the anion. Now it does this because it wants a full outer shell, and we call that the octet rule. Well, we still want stability for covalent bonds. So if you'll look on the second slide for me, it says, why do atoms bond? Well, you already know this. It's because they want to behave more like noble gases. So the stability of an atom has a lot to do, or an ion or anything, has a lot to do with energy. We want to, or elements want to behave like noble gases because they're stable and they have full outer shells. Metals and nonmetals, as you can see, gain stability by transferring electrons. So those are ionic compounds or ionic bonds. When two nonmetals interact with each other, you're going to have something different. So if you'll look at the next slide, it says atoms in, or slide number 3, it says atoms in non-ionic compounds share electrons. So there is no giving and taking of electrons. We're not transferring them. They are simply being shared. And we're going to see how that happens in a few different cases using Lewis dot structures. Now, the chemical bond that results from the sharing of electrons, we call that a covalent bond. So ionic bonds are where an electron transfer is taking place. A cation is giving away an electron, an anion is picking up that electron, so they are being transferred. A covalent bond is where an electron or two electrons or three electrons are going to be shared. So ionic is transferring electrons, covalent is sharing electrons. Ionic, remember guys, you have to have charges. In covalent bonding, we don't really care so much or worry about a charged ion or a charged particle. So charges are only dealt with for ionic compounds, and molecular compounds, we really care about what electron is sharing or where these electrons are sharing at. So ionic compounds or ionic bonds are between a metal and a nonmetal. They're transferring electrons. Covalent bonding is between typically two nonmetals, and they're sharing electrons, or they're sharing an electron, okay? Now, a molecule is typically formed, or this is what we would call a molecule, when there's a covalent bond. So we have called, when a metal and a nonmetal share an ionic bond, we call that an ionic compound. Or we also have another name for it, we called it a formula unit. So if we have a metal and a nonmetal that have transferred electrons back and forth between one another, then we have an ionic compound, or a formula unit, same thing. In terms of covalent bonds, when electrons are sharing, or when atoms are sharing these electrons together instead of transferring, we've created something called a molecule. So we will call these molecular compounds. So ionic compounds, metal, nonmetal, and that just means that we have electrons that are being transferred. We call that an ionic compound, or a formula unit. If we're thinking about covalent bonds, when two nonmetals share electrons, we call those molecular compounds. So a molecule just means that two or more atoms are sharing electrons to form this covalent bond. So molecular compounds have covalent bonds, ionic compounds have ionic bonds. Now, a majority of these molecular compounds are between two nonmetals, and that's really what we are going to focus on, are just between two nonmetals. So if you'll go to the next slide, it talks a little bit about diatomic molecules. A long time ago, you had a POGIL activity, where I asked you about a molecule. And we looked at compounds versus molecules versus elements. And then I think also there was mixtures in there as well. Now, we know that a diatomic molecule means that there are two atoms, because di means two, atomic means atom. So if I had H2, that's a diatomic molecule or a diatomic element. There are 7 diatomic molecules or diatomic elements, and they are listed in the parentheses there on that slide. So it's H2, there's also N2, F2, O2, Cl2, I2, Br2, 7. So we have all of these. What's really cool is that on your periodic table, if you were to have your periodic table and you were looking at it right now, there are 7 of them. There's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. If you make a line connecting those, I know hydrogen's not in there, but if you make a line connecting N, O, F, Cl, Br, and I, it makes a 7. So there are 7 diatomic molecules, and if you can remember that that 7 goes there, but then you also need to make sure that you add hydrogen into the mix. So it makes a little 7, and that's kind of a little helpful or easy way to remember that. Now, diatomic molecules just means that 2 atoms are sharing some type of an electron in their atom. So they're sharing electrons in this case. So if we were to go to the next slide, you'll see how fluorine can share electrons. So in terms of fluorine, let's draw, because fluorine, F2, that would be the diatomic version, that's what we would write. But let's actually see how they share. So I could have fluorine, and if I draw the Lewis dot structures for both of them, they're going to look the same. So fluorine has 7 valence electrons, so that means I'm going to draw 7 dots around it. So I'm going to have 1, 2, 3, 4, 5, 6, 7. Okay, so these are paired electrons, paired and paired. So it'd be really easy for another element to come in here and bond with this, or bond right here, because there's an empty electron place right there. Now, this fluorine is going to have the same thing, 7 valence electrons. So let's say we have 1, 2, 3, 4, 5, 6, 7. So there's another place right here also. So in terms of what will happen in this covalent bond is that this electron can fill the void for this fluorine, and this electron can fill the void for this fluorine. So if you're looking still at your PowerPoint slides, it will also show you how they are linked together, or how they can share. So I went from 2 separate things to now this little set of electrons here is what they're sharing. And I don't know why that F just became so much bigger than the other one, so I'm sorry about that. So if I look at this, this is one fluorine, and it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons around it. So it's stable. It has that full octet. If I look at this fluorine, it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons around it, so it's stable. So it's this bond right here that's what we call a covalent bond, because both of these fluorine atoms are sharing these 2 electrons, so that way they can have a complete octet. So if you have questions about this especially, please comment on the blog or send me an email. We're going to talk a lot more about them in class tomorrow, but I just wanted to make sure that we were all on board. Now, we can say that something has a single covalent bond when they share 1 pair of electrons. Well, you know a pair would mean 2, so these fluorine atoms are sharing a pair of electrons. So that means they have a single covalent bond. You could have drawn or written this another way. We could have written it as F dash F. Typically, we can show a single covalent bond instead of drawing these 2 little dots as a line. 1 line indicates 2 electrons. So if I wanted to rewrite this to make it all beautiful and show all of my valence electrons, let's do so. So I know that fluorine shares a covalent bond because we just saw that. So it would have 1, 2, 3, 4, 5, 6, 7, 8. Because this line represents 2 electrons. Because they share a pair of electrons. And then on this fluorine, it also is going to have the same thing. 1, 2, 3, 4, 5, 6, and here's my 7, 8. So instead of drawing them like that, we could just draw it with this line instead, and that shows a single covalent bond. So I'm going to pick back up with this tomorrow in class, so this is where I want to stop. If you have questions, like I said, please comment on the blog or send me an email and I'll answer them. You will have a quiz on this as soon as you walk in to class tomorrow, so make sure you're prepared for it. Bye! Have a good night!